Okay, so now I'm going to talk about the steps for an action potential. So you will see questions on this on your exam. Let's start with the first one. The first step that has to happen is that the presynaptic neuron, it could be one or it could be more than one, releases neurotransmitters. Okay, then these neurotransmitters open the ligand-gated channels. These ligand-gated channels are on the dendrites and the cell body. If sodium enters, and sodium has the positive charge, this is called depolarization. Type of a graded potential becomes more positive. But if chlorine enters, and it could also be that potassium leaves, but in that case, that makes the inside more negative, and that's called hyperpolarization. Only if the inside becomes positive and the positivity is strong enough, that will then lead to an action potential. So the depolarization in the cell body, the dendrites, then reaches the voltage-gated channels. This then opens voltage-gated channels, one after another. And the first ones that open are the sodium ones. And this is just an action potential. So an action potential is just these positive charges moving down the. Okay, next one. So then the action potential moves down to the synaptic knobs or the axon terminals. Calcium enters the synaptic knobs, which then leads to the neurotransmitter release. And so this exact thing happened in those presynaptic neurons to cause them to release their neurotransmitters. But now we're seeing it in the next one. Okay, now the inside is positive, but we want to get it back to negative. Getting it back to negative is called repolarization. So repolarization is when the potassium channels open. So these are also voltage gated. And so the positive charges leave the cell and the inside goes back to negative. And that is it. So what this is showing is basically those ligand-gated ion channels opening. So in this top picture, very little sodium entry, not enough depolarization. So we're seeing that these voltage-gated channels remain closed, and so no action potential occurs. But in this next picture, second picture, so here enough sodium came in, many positive charges are now inside, and then those positive charges were able to open up those voltage-gated channels. So then they started opening one after another, so just like dominoes falling. And so voltage-gated channels open, bringing the positive charges, and the action potential is just positive charges moving down to the synaptic knobs. Axon hillock is the beginning part of the axon. And so this is where the first voltage-gated channels are going to appear. And so again, it's just saying how the voltage-gated channels then open along the axon if the threshold is reached, and that is what an action potential is. And the action potential goes to the synaptic knobs. And so then, again, the channels are opening one after the other down the length of the axon. And so here, due to sodium entry and the voltage-gated channels are letting in the sodium. Repolarization meant negative, go back to normal. Okay, so here repolarization, close the sodium channels first, then open the potassium channels. When the potassium comes out, it takes out the positive charges to the outside. So taking out the positives gets it back to normal, repolarization. Now, at the end of the action potential, it does dip a little bit down to the negative from where we started. That's called hyperpolarization, and that part is normal. So I'm going to show you that on the graph next. Yeah, but so going back to normal. So once it is back to normal, then the potassium channels close. Instead, the neuron is ready to do another action potential. And that sodium-potassium pump is making sure that you always have a lot of sodium on the outside and potassium high on the inside by pumping these in the opposite direction. So this is just a graph of the action potential. So an action potential, when the inside becomes more positive, that's called depolarization. So the left side is just showing the charge on the inside of the cell. Okay, so we went up to the positive side. This is when the sodium channels open. It's then to go back to normal, repolarization, when the potassium channels open. Right down this way. Okay, so at the end of repolarization, the charge inside gets a little bit more negative than where it started, because if you look here, resting potential versus this dip here. But yeah, so this is just normal. And so they also call this hyperpolarization. And if you remember, hypopolarization was also called with the graded potentials if chlorine channels open and if it gets even more negative on the inside. But yeah, so really the definition is becoming more negative. And so a summary, at rest, the inside is negative. Threshold stimulus, this is the strength of the depolarization. So if enough sodium channels opened, then you can start an action potential if you reach this threshold. And so then it leads to depolarization. Repolarization is going back to normal. So here the potassium leaves the cell when those voltage gated channels open. And at the end, a little bit of hyperpolarization occurs. But then the potential goes back to the normal.